Okay, boys and girls, we're working with division patterns with Desmos. So let's always take what we know with multiplication and what we multiplying Desmos, and let's also take an account of what we know with division. The Healthy Wheat Bakery uses 560 pounds of flour to make 1,000 loaves of bread. Each loaf contains the same amount of flour. How many pounds of flour does the bakery use in each loaf of bread? You can use the power of 10 to help find the quotients. Dividing by the power of 10 is the same as multiplying by 1/10, 1/100th, or 1/1000th. So it says here, if we're going to take 560 divided by 1,000, so we have 560 and we have 1,000 pieces. We've got to break it up into 1,000 pieces or groups. We know our number is going to get smaller. It's going to get smaller because whenever you divide, your number gets smaller. Also, we know that because we're doing base 10 with the thousands, was all we really have to do is move the decimal, because when we divide by a base 10, when we multiply by a base 10, our digits never change. So if we look at our pattern here, 560 times 1 equals 560. Identity property. 560 times 1/10 is 56. We move the decimal back 1. Well, if we're doing 560 divided by 10, we're still moving the decimal back by 1 because our number is going to get smaller. 560 times 1/100th is 5 600ths. We move the decimal back 2. It is the same as 560 divided by 100 equals 5 6000ths. 560 times 1,000ths is the same as moving the decimal back 3 places, and we have 560 thousandths. And if we'd say 560 divided by 1,000 equals, moving the decimal back 3 places, 560 thousandths. So we know it's 560,000 pounds of flour is being used in a loaf of bread. As you divide by the increasing number of 10, how does your position? It moves to the left, and my number gets smaller. All right, another way to do it is the exponent. So if we have 560 divided by 10 to the third power, I am hoping that when you see 10 to the third power, you just know it is 1,000. But if we're not sure, we can go through this. 560 divided by 10 to the 0 power, it's like having no zeros in the base 10, which is 1. So 560 divided by 1 equals 560, which is identity property. 560 divided by 10 to the first power is like saying dividing it by 10, which moves the decimal back 1 spot, which is 56. 560 divided by 10 to the second power is like saying 100, and that tells me my thing is going to move back 2 spots. So it's 5 6000ths. So 560 divided by 10 to the third power is like saying 1,000. And I write my number. I just write my number, move my decimal back 3 spots, and it is 560 thousandths. Okay. Next page. All right, so now they want us to work in a little story problem. Ling uses 25 and 5/10 pound of tomatoes to make a large batch of salsa. He uses 1/10 as many pounds of onions as pounds of tomatoes. He uses 1/100th as many pounds of green peppers as tomatoes. How many pounds of each ingredient? Well, we're doing some comparing here, and we know that there are 25 and 5/10 pounds of tomatoes. If the onions is 1/10, so that means we're going to divide it by a 10th. So we can think 25 And 5/10 divided by 1 is the identity property, and it is 25 and 5/10. Doesn't change. By 1/10, I'm sorry, by 10, because if it's a tenth, we're dividing it by 10. So 25 and 5/10 divided by 10, I just write my numbers. No, my decimal's got to go back 1 because I'm dividing it in 10 equal parts. It's going back 1 spot. So Ling uses 25 and 5/10. Oh, I'm sorry. My decimal was here. It's got to go back 1 more. Sorry. And so we got 2 pounds and 55 hundredths. Is that smaller than 25 and 5/10? Yes. So we know that he is dividing his by 1,000 or 100 pounds. So 25.5 divided by 1, identity property, nothing changes. If we divide 25 and 5/10 divided by 10, it's 2 and 55 hundredths because I moved my decimal back. My decimal was here, I move it back 1. If I do 25 and 5/10, I'm going to just write those numbers, and I know my decimal was right here. There's 2 place values in 100. I have to move it back 2 places. So it's 255 thousandths. So let's complete the pattern. 32 and 6/10 divided by 1 is 32 and 6/10. 32 and 6/10 divided by 10. So I'm just going to write those numbers, put my pen where the decimal was. I know that there's 1 place in 10, so I'm going to move it back 1 place. 32, I'm just going to write my numbers again because I'm dividing it by a base 10 of 100. Put my pen where it was. I know there's 2 places in 100, so I'm going to move it back 2 places, and I get 326 thousandths. I can do the same exact thing here with an exponent. I know this is really 50 and 2/10 divided by 1. It's an identity property. It stays the same. I'm dividing it by a tenth by 10 because 10 to the first power is 10. Put my decimal where it was, move it 1 spot, and I have 5 and 2 thousandths. Put my same numbers down. Put 10 to the second power is 100. I'm going to move my decimal 2 places because there's 2 places in 100. 1, 2. My number's going to get smaller, so I move it to the left. It's 502 thousandths. All right, I would like you to go through these with your partner, and remember, you can just write an answer down, but if you really want to be a learner, you're going to go through these with your partner and know what those mean. Okay, then let's move on to the next page. And on this page, I want you to do 3, 4, 5, 6, 7, all of these. Okay, now let's move. Before we do all those, let's go to the algebraic, because sometimes we struggle with that and sometimes we don't. But when I look at this, I see my numbers are the same. It's just how much is it different in between. So that tells me I'm taking it times some base 10, so I'm going to put a 1 here. Now I look and I say, well, if I'm dividing it, my number got smaller by how much? My decimal moved by 1, 2, 3. That means it had to divide it by 1,000. If I look at here, I know I'm dividing it by a base 10, so I know I'm going to be using the same digits. Okay, guys, we're going to have to go to the next video to finish this.